All right. Now, spontaneity. Let's talk about it. In fact, hang on. Let's do it right here. If a reaction is spontaneous, that means it wants to proceed to the product side. Okay, so if you have a negative delta G, the reaction will on its own proceed towards the product side. Okay, how can we relate that to K? Well, it's this simple. If we have a negative delta G, then that means it's going to make products. The product side is favored. So the equilibrium constant would therefore be greater than 1. So if you have a reaction that is spontaneous and wants to make products, then you'll have more products than reactants at the equilibrium. So reactions that have a negative delta G, they will have large equilibrium constants. If a reaction has a Gibbs free energy that's positive, that means it's non-spontaneous. It doesn't want to go in that direction. It actually means the reverse reaction is spontaneous, which means the reactant side, as you've written it, are favored, which means the equilibrium constant must be less than 1. And if you have the rare scenario where delta G is 0, then that means the equilibrium constant is essentially 1. Okay, where neither side is favored. Okay, so, just by thinking about it, we can kind of derive that. Now, there is an equation that relates the two. So this table down here shows exactly what I was talking about. Ignore the natural log thing. You ain't got to think about that, right? But if delta G is less than 1, if it's spontaneous, excuse me, going to have a large equilibrium constant greater than 1. If delta G is positive, then you have an equilibrium constant less than 1. If delta G is 0, you essentially be 1. If you say, if we take this reaction we just got, if you say a reaction at equilibrium has a delta G of 0, then if we plug 0 in for delta G non-standard, you can derive this equation. And this equation says that delta G standard is going to be equal to negative RT ln K. So this is the equation that actually allows you to take the standard Gibbs free energy values and determine the equilibrium constant for the reaction from them. This relates the thermochem unit and the equilibrium unit. So you can get equilibrium constants from delta G standards. You can also take equilibrium constants and turn them into standard Gibbs free energy values. Okay, so delta G equals negative RT ln K. I'm not going to make you derive that. If you need that equation, I'll give it to you. You don't have to memorize it. So they actually want you to solve for that here. Okay, so let's see, can I type this? Delta G standard equals negative RT ln K. So use this equation to solve for the equilibrium constant for this reaction at 298 Kelvin. Go ahead. Show you what happened here. So I got D as my answer. Really comes down to if you round or not. If you round this to 36.5 and you just do e to the 36.5, you don't leave the full number in your calculator, I got 7.05 times 10 to the 15. But if you leave the full, then I redid it without rounding, and I did e to the full number, like 36.5276978, and then I got 7.31 times 10 to the 15. So as long as you got 7 times something to the 15th, you did it correctly. It just is affected by the rounding, right? So what did we find? Well, we found the reaction has a spontaneous delta G, okay? It's a negative delta G, and we got a large equilibrium constant because the product side is favored. Okay, go ahead, try this one. I forgot about this problem. That's okay. I want you to calculate delta G standard for this reaction using the standard Gibbs free energy value. So you're going to have to calculate delta G for this reaction, and then I want you to calculate K for it using this delta G equals negative RT ln K equation. So find delta G first using the standard Gibbs free energy values, and then solve for K. And then this will be the last thermal problem we do. All right, folks. I got K equals 0.323. How did I get that? Well, I got delta G standard for the reaction is positive 2.80. Okay, we use the delta G of formation values. products minus reactants, so 2 times the 51.3 minus 99.8, that's a positive 2.80. What does that mean? That means this reaction is non-spontaneous. What does that mean? That means the reactant side is favored. That means we should get an equilibrium constant that is less than 1. What do we get? We got an equilibrium constant less than 1.